So let's talk about the calculus. Calculus people, like people then in the AP then love to test you theorems. Theorem is my favorite part of teaching calculus, even though they are kind of pain in the butt to remember. But usually my result shows me that I do theorem better than a lot of teacher is because I will keep test you until you actually understand it. So today I want to introduce you a couple theorems. One is the IVT, intermediate value theorem. But before theorems, what kind of things I love to test? They love to test says the first concept is says, well, what does limit exist mean? Right? Limit exist. Limit exist means limits x approach to a from the left of f of x equal to limits x approach to a from the right of f of x. That's limit exists. And the graph looks like something like this. Limit x approach a exists. Even though I have a black dot on the top, it still exists. Because limit approach to left to right is all equal to the same value. So limit exists that way. When the limit does not exist, limit does not exist, with three situations. One is when limits x approach to a from the left of f of x does not equal to limit x approach to a from the right. Well, kind of like first one is that not equal. The second one is unbounded behavior. Now this one gets kind of confusing because now with the one-side limit, we actually say that could exist, but it's going to infinite. So 1 over x squared. The third theorem is oscillation. Not the theorem, sorry, this is not theorem. This limit does not exist on this three situation, oscillations. So the perfect example of f of x equal to sine of 1 over x. So those are the things that they love to test. Third thing, I'm gonna write in red. Very often. Its definition of continuous. On your test, on AB test, I didn't ask BC, but on AB test, I'm just gonna ask you, what is the definition of continuous? What's the definition of continuous? Okay, can you tell me? What is the three requirement for a function to be continuous? F of A has to be defined. Okay, so I'm gonna draw it out. F of A has to define. So f of A is defined in this case. This is A, this is defined, but is that continuous? No, let's one more. Can you already finish that, Isabel? Now remember, it's on your test. F of x must exist. No, it limits x approach to A of f of x must exist. Which just go back to what does exist mean? Exist means limit x approach to left to right has to equal each other. This exists, but it's still not continuous. One more thing. Yep, if you go to f of A. And the only thing that you can do is make this going like this. And now it's continuous because this dot is filled in. And then you are continuous. You can build a roller coaster there. It's still going to be a bumpy ride, but still you're not going to be deadly. Okay, so now let's talk about squeeze theorem. Wait, should I talk about squeeze theorem first? squeeze theorem first, because that's more fun. Squeeze theorem. Before we talk about squeeze theorem, do you remember this oscillation one? Do you remember what equation is going to cause that oscillation? Good job. F of x equal to sine of 1 over x. And that graph looks like something like this. Okay, I feel like answering all the questions. I need other people to answer questions. Okay, so, and I know the answer of this one, so I'm not gonna ask them. What is the range of this function? Range. Let's ask Grace. Nice. Good job, Grace. Some people think, anybody's thinking about negative infinity to positive infinity? No? It's negative 1 to positive 1. Range means y value, what y can be, from what the lowest y value can be to what highest y value can be, right? You are oscillating between negative 1 to 1. So great, because if I graph y equal to 1 and the y equal to negative 1, then it's oscillating between 2. Got it? And we don't know what happened in the middle, because that's when Mr. E got infinite slab in the middle, and Mr. E won't be able to tell you that he get forehand or backhand, because he cannot tell. Now here's the thing, this function can be easily altered and to become something. Now we know the range is sine of 1 over x. The range is between what value and what value? Negative 1 and 1. And is that equal to? Yeah, that's equal to, because that's that. But this is not what squeeze value says. The squeeze value theorem says it's actually something interesting. I'm actually give you an example. I didn't give you the theorem, but I'll give you an example. One of the most common example in the squeeze theorem is involved sine of 1 over x. It's beautiful. I'm not lying to you, it's beautiful. Now, what I want is, this is the question. On your test, you're going to see this question, and I'm going to tell you, you're going to see this question. Is sine of 1 over x. But there is x in the front. So this is a brand new idea. There's an x right in the front here. And you're like, wait, there's an x in the front. What's the difference between this graph and the previous graph? Well, the idea is we don't know. So what we're going to do is, how do I make this function look like this function? How? Multiply by what? Multiply by x, right? So, but remember the inequality. On your review sheet, there is an inequality. It's called compound inequality. It has a left function and right function of negative 1 and 1. So your whole goal is to make this look like this. Look like it. Now I'm going to get this, and you say, oh, okay, well, all right, I got this. All I gotta do is multiply by x according to what Sean says. So if I multiply by x is equal to negative x, the whole thing is gonna multiply by x. And that's gonna be like this. You guys see that? And you guys, what am I doing that? Since that sine of 1 over x is oscillating between negative 1 and 1, this function is going to oscillating between negative x and x. That's interesting now, because this function here, I can use limits approach this, because we try to find the limits of the middle function, but we can because we don't know how. But can we find the limit of this function and this function? can I say limits x approach to 0 from the left side of a negative x and limits x approach to 0 from the right side of x? Can I figure out what that is? What's limit x approach to 0 from the left side on negative x? Is it equal to what? When you do a limit, the first thing you do is what? Plug in 0. So what am I going to get? Don't tell me negative 0. It's 0. I'm going to plug in this one. I'm going to plug in 0. Wow. The range is at 0. Because if I limit x approach to x sine 1 of x, if I approach 0 from the left side and the right side, and they're all equal to 0, that means this is equal to 0. Does that make sense? This gives you this, right? Now, this is not the most amazing part. The amazing part is look at the graph. Are you guys following me so far? Because if I have the top restriction function, it's going to 0. The bottom restriction function is going to go to 0. The middle function had to squeeze into the 0. And you guys don't understand what I meant because you guys didn't see the graph yet. You didn't understand the beautiful part about math. The beautiful part about math is this. This is this function, right? And I'm going to introduce a new function, says x. We're going to say negative x. And then we're going to have a positive x. And we're going to unhighlight this. And we're going to just keep this right now. And I'm going to type in another function says x sine of 1 of x. You guys pay attention? Okay, the magic is about to happen. You're like, I don't see anything yet. Wait. And it looks like this. Remember, the purple line is positive x. The green line is a negative x. Now look at here. Limit x approach 0, it was oscillation. It was undefined. Do you see that? It's oscillating into what? 0. Is this pretty cool? I thought it was pretty cool. It's a squeeze theorem. It squeezes the function into the 0. And based on that inequality that we do. And not only this, does that apply to x squared sine of 1 over x? It does, because I can change this to x squared, right? I can change it to x squared. I can change this to x squared. I can change it to that. And the only thing is I multiply the whole equation by x squared. I take that domain, I take a range of the original function, and I insert it to the new equation because I want to make new equation works. But then look at x squared. I want to show you x squared. It's even more cooler. It looks like this. But look at this. It follows like strictly. Like it follows that goes into the 0. I think that's a very, very cool thing. Like it just like amazes me every time. Like a mathematician can figure out this very easily on their own. And I will say like mathematician is like one of those creative people in the world. Is to figure out things like this. And oscillating strictly follow that restriction, the x squared and negative x squared. So there goes squeeze theorem. You're gonna get one question about squeeze theorem on your test. It's probably deal with sine of x, sine of 1 of x, and cosine of 1 of x. You just had to remember. You just had to see how it worked. You're gonna get another question called intermediate value theorem. If you understand this theorem, it's gonna give you a 2 points on AP exam, minimum 2 points. One is somewhere in FRQ, and one is somewhere in MCQ. And so there's about 2.2 points threshold that you're gonna get. And it's a very simple theorem. It should be taught in Algebra 2 because I teach my Algebra 2 class intermediate by theorem. And I will teach you again at pre-calculus. And I will teach you again at calculus. If it's my style of teaching, I will teach all 3 classes. But it was really simple. It was really simple. Most of people can get it and can understand it, no problem. But you gotta learn how to read theorems now. Theorem is, I'm gonna break down such an easy way for you guys to understand theorems, so you have no problem. So intermediate theorem says they have conditions. Usually I'll give you a condition. F of x must be continuous. And you gotta remember what is continuous, right? Continuous says f of a must define. Yep. And limit x approach to a of f of x equal to f of a. F of x must be continuous between a to b. Good. Great. And I'm done with this. I say I'm going to do the next one. The next one says f of a does not equal to f of b. The third one says there's a value k is between f of a and f of b. So a notation will be like k is between f of a and f of b. So the result is this. F of c is equal to k. But I'm going to write out the last part result. Then there is this 1c in a and b. So this is the result. I come up with a very easy analogy for a student to understand. I use a water bottle. I'm a very unhealthy person. I don't drink enough water. Every day, sometimes I drink no water, or I drink as much as this water. Huh? So that's not very healthy. Someday I probably have kidney problem. So I'm gonna rely on some of you guys to donate me a kidney. You got me. So there's a label, Aquafina. So next time you see me, Mr. Do you drink water? Remind me. So this bottle, I have to drink it. So Luke's really worried about my health. Come in the morning, first period says, hey, Mr. drink of water. I'm gonna take a picture of it. I'll take a picture right here. Right? And this is your F of A. This is a K. This is a K. This is the F of A. This is a K. Okay, so I'm gonna show you here. Hold on a second. I'm gonna show it on the screen so that way you guys can see it. Full transition. Shang is back. Sub to Shang. Whatever you want to plug in your channel name. You guys speak up louder. Nobody can hear you.
Mansington.
Okay. Anyway, so this is a F of A right here, and this is F of B. This is your K values right between those. Water is a continuous function. You cannot take a scissor and cut the water. It's a continuous function. Does that make sense? So Luke says in the morning, says, hey, Mr. You got to drink your water. I'm going to take a picture of this. I'm going to take a picture at first period and come back after school. And if you take a picture at here, my water goes down here. So that means somewhere in time, this water has gone down to the level. this line right here, which is we're gonna call the one line here as Aquafina here. It must pass through here. It must pass through at least once. Because if you take a picture in the afternoon and it's down here, good, Mr. You drink water. I don't give a shit how many times you drink the water, because I could drink it and refill it and drink it and refill it. It could occur more than once. That's why it says at least 1C. So I can drink it, but long as I get to here, I'm good. There is a C value gonna give me K, but does not define which C value is. Does not define when. So let's look at in terms of graphing. Let's go back to the iPad positions. Okay. Becoming professional streamer. Now I just need to know how to override school Wi-Fi to stream on Twitch.
You're on Kick.
What is Kick?
It's basically just a worse version of Twitch, so that people can do illegal stuff.
Oh. True.
But it is when you're a kid.
All right, so this is the intermediate value theorem. So what is that saying? That's just saying that if I have a function like this, and this is f of a, this is f of b, and k has to be here, and this is the a right here, and this is a b right here. Okay, k usually are k at 0, but in this case, k is not 0. So if this function is continuous, the easiest continuous function is going through here. Yes, you're gonna have you have to go through k, and that's a c value. At least you're gonna go through once. Now, can it go through more than once? Yeah, if you have some type of polynomial. Now, I'm gonna redraw this. If I have some type of polynomial, I could have like this, right? And that's also continuous. How many times I go through? 1, twice, 3 times. We're gonna call this C1, C2, and C3. So you can have more than one C. So therefore, yeah, the simplest one just goes straight line, and that's continuous function. That is continuous function, and that's whatever, just go in straight line. At the minimum, this must be going to the C here. Or you can have something like this. It must have a C here, C here, and C here. You could have 3 times occur. Now, what kind of function? I will give it to you. On your homework, you might represent this. This is one of your homework questions. Says f of x equal to x cubed plus 5x minus 3. And then they say between 0 to 1, prove that there is a 0 between the intervals. Using intermediate value theorem. Then guess what? All you gotta do is f of x is a polynomial, and all polynomials are continuous. All polynomial. It doesn't matter which kind of polynomial. Quadratic, cubic, all polynomial quadratic. And then they say f of 0 is what? What is f of 0? -3, because I just plug in 0. What's f of 1? No. If I plug in 1, it's going to be 1 plus 5, 6. 6 minus 3 is 3. So f of 0 is -3, f of 1 is +3. Then you say, okay, well, they're not equal to each other. Now, is 0 between f of 0 and f of 1? Yes, because that's true. So IVT proof that there is at least one C. Where f of C is equal to 0. Because 0 is a K. Yeah, because there's no way at -3 right here and +3, and I don't go past the label. It has to go to 0 because 0 is between -3 and +3. What time we get off here? Okay, we got 6 minutes to talk about next question. It's interesting. Question about us. F of 0, sorry, 0, less than 0. Now the next one is I am gonna give you a question that looks like this, but I also have to teach you how to use decimals. You guys don't know how to graph decimals, so 3x squared ax minus 4 when x greater than 1 and when x is less than 1. So first of all, you guys learn how to graph decimals. Yeah, ax. And sometimes you could have fun a. So I will say, hey, find the value of a where f of x is continuous from negative infinity to infinity. So continuous the whole way. Now, obviously, this is some type of piecewise function. For example, on my pre-calculus class, I will ask you to graph that ugly function there. But this is even harder because this one has an a. That ax is floating. Is only one situation to make them continuous. What the hell is going on there?
There are goobers outside.
Huh?
There are goobers outside.
What is goober?
I've been saying a lot. Just they're goobers. Little silly guys.
Okay, so I can use decimals. So guys, get your decimals out. Learn how to use decimal is also part of the curriculum. Later on, we're gonna teach you how to use So we got 3x squared. So 3x squared. How do I draw a piecewise function on decimals? You can do that with your graphing calculator as well. So you're gonna say, well, usually I do y equal to, and I will do a brace, and I will say it's x is greater or equal to 1, like this. I will do a brace. So you see that parabola is cut to one section only when they are x greater than 1. Are you following me? Do you know how to get brace? No? Okay, I'm going to type in again here. You click on the ABC on the button here, and you see the bottom here next to the bracket, right next to B and B, below that, there's a brace. And then that's going to be x greater than 1. And type in brace, open brace, and then close brace. And you're going to type in another function. The second function I want you to type in is y equal to ax minus 4. Now, a is just use letter a because they know the decimals know is constant, plus 4. Now, when it bottom says add a slider, I want you to add a slider here, but I'm going to put a restriction. I'm going to put a restriction that says x is less than 1.
Is it plus 4 or minus 4?
It's minus 4. And then you're going to add a slider. Now, is this function continuous? No. Where is not continuous? Which x value is not continuous? 1. So look at this. You can actually play with this a. You can have a slider, just play with it. Do you see that? There's only one point that those two lines connect to each other. Right?
How did you get it to do automatic?
It just had to add a slider. So if you type in ax minus 4 and they will say add slider, it just add slider.
And if you just click the slider, it'll go.
Yeah, you play the slider, they will play. So that's what a math equation can do. And there's an infinite amount of choice between those two values. Between -10 to +10, there's infinite amount of choice. But there's only one choice is correct. So now we're trying to figure out what the right choice is. We say, hey, let's do limits as x approach to. Well, where does this continuous?
7.
No, where is it discontinuous? Where is the function discontinuous? At 1. So 1 from the left side. 1 from the left side, I have to use which equation? Which equation I'll be using? Ax minus 4. Good. And why do you have to use limits? Because use limit is the proper way to illustrate something. And then that's going to be 3x squared. And if you don't use limits on FRQ, they might not give you points because you didn't do the calculus wants you to do. Some people just plug in number, which is applied, you're gonna get the same answer as well, because eventually you plug in anyway. So it'll be a minus 4 equal to 3 times 1 squared. So a equal to 3 plus 4, a is equal to 7. And you just proved it. Some of your question today, it's gonna be very interesting. It's gonna be really hard. Okay, so you gotta figure out how to do it because I might give you 2 intervals. So if you choose this to be a 7, guess what? The function is continuous. And we prove algebraically to be able to prove it. So on your today's homework, you're gonna get some interesting stuff. Sometimes you might have 2 intervals, sometimes you might have 1 intervals. Yeah. Any questions here? Yes.
But what do you mean by like 2 intervals?
2 interval is maybe you got 2 variables too. You got a and b, and you have 2 intervals. The one I'll give you, this is one of your homework question. You can try it. F of x is equal to 2, and the middle function is ax plus b, and the other one's -2, and x is less than -1, x3, x -1, and x greater than 3. So this is one of your homework question. You can try to do this one. And now I'll give you a much harder one than this one too. But there are 2 points that's discontinuous here. Can you figure out which 2?
I can use decimal.
-1 and 3. No, you cannot use decimal. You have to figure out by hand. And then once you got the answer, check with decimal, are they continuous? If you got an answer, you figure out the straight line is going to connect all of them. But there was only one possibility between A and B, because A and B both have infinite amount of choices. Only one choice that they can be continuous. But you got to figure out how to use limits.
So for this type of decision, we would ask letter for A and B to confirm the answers.
Yeah, but you're not supposed to use slider. You're supposed to solve with the algebra now.
Right, no, I know. I'm saying the one we do.
Yeah.
We do. Make the